Hi there, welcome back to 8-bit to 32-bit. Today we're going to look at something slightly different, which is going to be a program called Atanua. And this is a really good program. It's free, it's real time, it's an emulator for logic chips, and you can basically have real-time inputs, outputs, visualizations, and you can see what's going on. So, based on a wicked video from Ben Eater, kudos to you Ben, for designing a VGA card from logic chips. This is going to be the start of your logic board using logic chips to generate a signal, and we're going to follow it through and see how we go. So what you need to do is you need to go and download yourself a copy of Atanua. So our first edition, we're going to add a 8-bit counter, but it's going to be made up of two 4-bit counters because we don't have an 8-bit counter. So the chip we're using at the moment is the 7400 series, and it will be a 74LS193. The 193 will be our 4-bit counter, and basically it'll be able to count up to 4 bits and then pass a carry-on bit across to another chip, and that's what we're going to do. So on the left hand menu we're going to scroll down in our chips. We're going to go and find the 74193, and we can drag and drop it, and we're going to get another one because we're going to need 2 of them to make 8 bits, and we'll drag and drop the other one over there. So we can actually use the scroll wheel to zoom in, and we can actually use the mouse to click and drag in and out. So we've got 2 chips, and we need to know what the inputs and outputs are. So the inputs are, again, going back to Ben Eater's video, we have a clock signal which will generate and it will count. So obviously on the chips we can look at various items. We've got things like pin 2 is a QB, and then we've got pin 3 is a QA, and various other ones. Obviously the power on this chip in this program, in the emulator, is already dealt with. We don't need to think about it. So the top left pin and the bottom right pin are dealt with. So that's why they're sort of like greyed out and gone. So we can work out what we need to do now in order to get a clock signal, and then work out which pins we need that clock signal going through. Okay, so what we could do is we can add a clock signal with an actual clock, or we could add a clock signal just using a switch. So what we've got on the input menu is a button, and we can drag this button down, and the button has one input, and what we need that button to do is to go to the clock input on this chip. So we can either count down or count up. So if I click on the count up and drag it to the switch, although you can't see anything happening, this is actually live. So what we could do is have an LED as an output. So what I can do is take my out, which will be LEDs, and I'll take a red one. And then if we look at the output of one of the LEDs, so let's go to pin out across here. Let's have a look. What have we got? No, not the carry. Carry is going to go across the other circuit. That's the borrow. Clear. Okay, let's go down the bottom. QD, QC, QA. Okay, so QA, take that up. QA is our first bit. So every time the bit 1, which represents the number 1 in decimal, happens, our lamp will light. Every single time. And what will happen is then, so we've got QA and QB and QC and QD. There are 4 bits. They will turn on and they will go up in binary, and we can add in basically the other stuff to see that happening. Once we've hit our top of our 4 bits, there will be a carry, and the carry is another pin, and the carry will carry across to the other chip, but it will become the input on its clock. Okay, so I've just basically rejigged a few things. I've added in the 4 LEDs you can see down below, and they are 4 bits. So starting from right will be bit 1, which represents a 1, then it's a 2, then it's a 4, then it's an 8. And with my switch on 0, if I click it, I get a 1, then I get a 2, I get a 3, then I get the 4, and a 5, 6, a 7, and an 8, and then it turns over. We now have, I've added in 4 green LEDs, and basically the reason I've just distinguished them is the red is the right hand chip and the green are the left hand chip. So what we've got is our right hand chip is now counting, it'll count up to 4 bits, and then what we want is the carry. So basically once it's run out of numbers, we want that carry to take over, and that carry is then going to end up going to be the clock on the other side. So that will go to this pin on the other side, and again we can connect the chips to the LEDs, or I should say the pins to the LEDs, in the same order. So we've got bits 1, 2, 3, 4, so bit 5, which will be this LED, will then end up going to this pin here. And again, we can take the second bit, so same as looking at the right hand side, we'll go to this pin here, and then the third bit will go to this pin here, and the fourth pin, which will be our 8th bit, will go to here. Okay, so we've got all our pins, and we've got our button, and we can keep clicking, and as it goes and we click, 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 it will eventually keep passing through the numbers, and our 8-bit register will start to add up, and we'll see what is effectively a binary number system going through. Cool, so I've got rid of a few things, added a few things, and what we've got now is a button 1, which is our reset. So that will reset everything back to 0. And what we need to do is add in the clock. So our clock will be our frequency, it will generate a signal every X amount of seconds. In this case, I'm going to go for 2 Hertz, so it's happening every 2 times a second. And I'm going to add it on the right hand side here. So the clock is going to do basically what our button 0 was doing. So we need to add it back into our clock, which is our count up. So you can count up or count down with this chip, but we're going to count up. I'm going to drop that into our count up, and as soon as we do that, we'll see our LEDs start to flash. And they're building up in sequence because this is binary, and every time they get higher, then the green light's on, count up to the top, and eventually they'll do that carry, and then the next light will light. So but we've got a nice 8-bit system here, which will count up to 255, and what we're going to do is we're going to eventually work out another way of only counting up to 100 with another chip, or a couple of chips actually, and we'll see how we can limit this system to counting to 100 and then having an impact and doing something completely different once it gets to 100. So there's no software involved, this is purely logic and connections. So what I'll do is I'll do a separate video with how we work out the binary and then the next chip, which will limit us to that 100. We can make it 110, but we're going to do 100. And then we'll set a different lamp, and we'll have a lamp that lights every time it hits 100, and the whole system will reset at that point. And that is basically where Ben Eater was going with his video, where you need to know that you get to a certain point and you reset and you carry back on your horizontal signal or your vertical signal. So we'll sort that out in the next video, but hopefully this is quite cool. You can go and download and play with this software. Thank you. Right, catch you next time.